This is the roadmap overview, storage provider meetup. It was about time to do this, um, primarily because we've been going through a pretty significant revision to this document. ScPri.me/roadmap will get you to the latest. You'll note if you've been watching it over the last, I don't know, 1 to 2 months, that it's been undergoing significant updating and it's not completed yet. We're still actually adding some things to it. We have a couple of pieces that we'll talk about that aren't currently listed there as we go through this whole program. I'm pretty excited about this, but at the same time, I don't know how we're going to get through it all. Um, if you start back in 2010 and look at it when it was almost nothing and growing up, relatively, we haven't really gotten very far yet, in terms of how much storage is going online and how much is needed and what it's all for and so forth. That's just about to happen. And this chart, nothing has proven this chart incorrect up till now. And I don't think there's anything that would suggest that the chart's going to be proven incorrect. So the whole idea here is just unstructured object-based cloud storage market in 2023 is fairly huge. And it's got a pretty good, compound annual growth rate forecasted through the next decade. But that 14% number doesn't really take into consideration what that chart looks like. That's if we just stayed on kind of a straight line from what we're currently on, that's where that number comes from. So, we feel really good about the dollar numbers that are here, when you take a look at that chart that we just looked at. And so that's essentially what we're shooting for as a project. This is a graphic that shows up on the XNS website that I think really highlights what we've built. At the end of the day, we use this thing called the renter host protocol, which, essentially describes two sides, the renter and the host. The host is all the storage providers. It's all the, examiners and licensed providers that are out there. And on the other side is the renter. And the renter has been the piece that we've been working on behind the scenes and in front, whatever, for the last several years, the relayer. We finally brought it to market in July 1st of this year. And I think a lot of people just don't really grasp that, for whatever reason. I'm really proud of this piece of software that we've developed. And yeah, we're going to have some shakeout, we're going to have some bugs, we're going to have some things that we have to work through. We're going to have use issues where people show up and say, oh, this happened and, we didn't expect or whatever. But it's working wonderfully. And it's really, really, really a game changer. And that's what we're really going to go through here now in this roadmap overview. So without further ado, I'm going to turn the first one over to Henry, and he's going to talk about a piece of software that's built around the relayer itself, that's listed as first on the roadmap overview. This is Relayer MT. So go ahead, Henry.
Thank you. So when we returned from our kind of summer hiatus in the last storage provider meetup, we talked at length about all the efforts that we're doing to help train up providers or partners and get our partners prepared with essentially all the tools, all the knowledge, all the training that they need to go out there and tackle and win storage deals. So one of those pieces that materialized over the summer is called Relayer MT. So while we had kind of the core relayer functions working a couple years ago, as you mentioned earlier, it was in the sense that, having a car engine, while that is kind of the base of the car, you still need the rest of the car around it. So that's what the relayer UI became. But the relayer MT is the fleet then. So this is a relayer UI deployer. So this is a layer that kind of sits, and it's a manager, kind of a hypervisor, if you know what that is. And it essentially manages and deploys multiple relayer containers. It has all sorts of cool features built in that make proxy management really easy. So it can generate a nice URL for you and your relayer use. It's really actually kind of neat. And in fact, it's so neat and it's so good at managing relayers that probably it's going to become the basis of all relayer installs moving forward, even if it's not in the MT mode. So it's just a really good way to spin up and spin down and control relayers. And I think we've seen internally that there's probably a case to be made for some of that functionality to come to the basic relayer anyway. So who's it for? At the end of the day, it is kind of oriented toward partners. It's to make their life much easier when it comes to things like tracking billing, when it comes to spinning up and allocating resources for relayers, some of the nitty gritty kind of networking, proxy stuff, making sure everyone has a URL that's kind of just for them, and kind of allocating resources in a way that makes sense. Potentially even like load balancing kinds of things. These are the kinds of things that you have to think about when you are doing this at a professional and kind of a commercial level. And if you've took those responsibilities on, then this makes that really streamlined and really straightforward. And we've so far had really good reception to it. So I've talked a bit about the benefits and the availability. Ken could maybe help me a bit with that one. I know it's already in the wild right now. So we've distributed it first to our kind of partner channel. They know who they are. And anyone, if they're interested in becoming partner, of course, xns.tech, we try to make it very easy and straightforward to do that. But Ken, what do you think the future of Relayer MT is?
Um, I'll tell you about the present first. Right now we've
Sure.
sold 3 of them, and they are a for sale, device in our ecosystem. They cost money. The deal is that we have a hardware version that we're selling right now, which is based on Supermicro. We've sold 1 of those, and we've sold 2 of the software versions. And the deal is as this data center sort of piece, they're site licenses or not site licenses, but partner wide licenses. So if you buy one, you essentially can set up as many Relayer MTs as you need. The future for the MT is that not only will it be for partners, but also as we grow into SME and then enterprise, there are going to be situations where enterprise managers will need to spin up multiple relayers inside of an organization, maybe for multiple locations or departments or divisions or whatever. And then the MT will be for them as well. It's never going to be just a simple, for the average user. It's a very much specific built around being a data center type provisioning tool. So there you go.
Yeah, thank you. So that's that's actually on our roadmap. That's the very first item because that is kind of already in the present, but still lots more coming forward. And I think it's going to be a really important piece to our product, not just our product portfolio moving forward, but a really important piece to actually getting a ton of data on the network. I think if we think of it as terms of all the data going up on the network, what percent of it is likely to flow through a Relayer MT? I bet it's over 50%. I think this is going to be a really key piece moving forward.
And the way it works with EMT, the whole notion here is that the partners are going to stand up relayers for customers as the trusted service provider. And the deal there is that, as always, on premise will often and probably in a majority of cases be the place where the relayer is going to live, because otherwise, if the relayer lives with the partner somewhere, there's a network hop from the customer to the partner, then up to the network. And so a lot of customers, probably most, are going to prefer to have an on-premise device that goes directly from their facility up to the cloud. And then, there are circumstances and situations, though, where the partner is going to stand up customer relayers, but the customer doesn't have, any people on staff to really manage, or, they don't have a great pipe to the internet themselves anyway, so they're not really too concerned about that. Or for a lot of reasons, there may be some circumstances where they want the partner to handle the relayers for them. So that's where the MT comes into play, because bang, you spin up new relayers, spin up new relayers, spin up. But the other thing about the MT is it also highlights that we're going to be, working hard on our S3 compatibility, which we'll talk about in a minute, for provisioning permissioned buckets. So a relayer is not always the answer for a customer. But when it is the answer and you have many of them that you have to spin up rapidly, the MT is the thing to do it. Okay, I'm going to move past that. It is live today, but it's on the roadmap because We still are provisioning, working on the licensing for it. We're still doing development around, how we actually ship it to the customer. The two that we sold this last week, we're about ready to hand over and let those guys get set up. So there's still a little bit of development work that goes on there. The next piece is a pretty big one, and it'll take a couple of minutes to work through it. And we won't really cover all of this, but this will keep coming back up through the rest of the presentation. We have this big task ahead of us that we're going to call the Conductor Kafka Refactor. Now, you may not know exactly what Conductor is, and if you don't, what we've really come to now at this point in the project is we've really now put names on everything, right? The relayer's always had a name. It had a name even before we forked. The examiner came along about middle of our project, somewhere, in about 2019, 2020, somewhere in that neighborhood. And then on the contracting side, we forked over a piece of software that Luke had developed called Muse. As with all of the SIA software, we really didn't get very far with the version that we forked over. We realized very early on that we would have to do a lot of refactoring, a lot of work, rewriting, and that software doesn't bear much resemblance to the original Muse at all. It's been rewritten. And that rewrite is called Conductor, and that's the contractor that talks to all of the providers. So when you're getting a contract with the corp, you're getting it through this Conductor. Now, what happens is Conductor has a lot of data that it's storing and shedding off and keeping track of in all of these contracts. And that's just today on a fairly small network of a couple thousand nodes. As we grow and scale, we knew that we were going to have a lot of traffic flowing through there. And so the next step that we looked at, in terms of being able to handle that was this event streaming tool called Kafka, which essentially allows us to aggregate a ton of data coming in and flowing out. And that's set up and working fairly well. We've had that working now for a little over a year. But what happened, if you remember back in, I guess it was probably May of last year, we got in and started messing around with contracts. We were trying to clean up some things with stale or stagnant contracts, and we blew up the contractor, right? We realized that the contractor was not robust or durable enough to really go forward. So we spent the last year really redoing that. We built the Kafka cluster, we set all that sort of stuff up, and now it's in very good shape. However, what we now understand is that there are a whole bunch of pieces of the puzzle that we need to take care of in order to be able to provide servicing that we've talked about at length. So one of the things that we're going to talk in a slide coming up is metadata backups in our own cloud, sort of an inception type thing where, so you get a metadata backup for your examiner and then you want to store it somewhere. And a lot of people have tried to do sort of recoveries on, licensed full providers or whatever, because, the metadata got corrupted or they, a drive failed or something like that, and they pulled from their backup. But they found that the minute they recovered or restored the metadata, that it blew up their node. Because what's happening is there are always changes going on to the contracts. And when you recover a contract from, before, one that you had backed up, what happens is it talks over the blockchain to Conductor. The two are in disagreement. Yours is out of date. And there's no current way right now to go out on the blockchain and recover that information. Without going too deep into that architecture, we've talked about it before, but our whole blockchain project starts out with a proof of work blockchain that runs underneath everything. And that's where transactions are all validated and so forth. And then on top of that, there's what we used to call a layer 2 state channel. Layer 2 is now taken on a whole different sort of meaning. So we won't really call it an L2. We'll just call it a state channel scripting that's going on over top of the blockchain. And that's where our contracts live. That's where contracting takes place. And on that state channel contracting, what ends up happening is it doesn't work on a transaction basis like you might suspect. In other words, when we make a contract with your provider and then something happens between the user, the relayer customer, and your provider, they upload more data or they download stuff or do things along those lines. What you might think would happen is, oh, okay, new data got uploaded, so that'll print a thing off to the blockchain and I'll be able to monitor that and see it, and and so forth. That's not how it works. What happens is when you form a contract with us, there is a transaction that gets printed to the blockchain. Then at the end of the contract period, which is typically 30 days and it runs about 6 weeks in our case, because there's a renewal period of a couple of weeks, what ends up happening is there's a closing revision. In other words, at the end of the contract period, a transaction gets printed to the blockchain to reflect anything that happened along the way of the contract. And then at the final, closing of the contract, there is another transaction that's spit out to the blockchain. So there's 3 transactions that go to the blockchain for any contract. Everything that happened in between is opaque. And that drives everyone crazy. And it's really not a great place to be right now for the project, because what happens is the only way to actually see that you're getting paid fairly or that things are happening is to wait until the closing contract comes through and see exactly what you earned and so forth. But you have to actually watch your wallet balance the whole way along, because funds are locked up on your side, which is the collateral. Funds are locked up on our side, which is called an allowance. And that funding is going back and forth between 2 outputs. And then at the end of the contract, assuming everything went well and the storage proof passed and everything, then that output gets freed up for you and those funds get unlocked and sent to your wallet. So we know we have a lot of work to do on that to make that accounting less opaque and to make it much more cleaner to you guys. That all starts right here in this slide with this Conductor Kafka refactoring. And part of that is that we have to be able to identify sector IDs. That's the whole big thing. Right now, we don't identify sector IDs. What happens is that when we form a contract with you and data is uploaded and stuff, you choose the providers. I love how my hands just disappear when I do that. Yeah. Anyway, the data is uploaded and it goes off to the providers wherever, and we don't have any real sense of that. We aren't following that. We aren't monitoring that. But there's no reason why we shouldn't, right? We don't want to know what you're uploading. We don't want to have information relative to your metadata. That's control that you maintain and keep. That's our key unfair advantage over everybody else that's doing this. We don't want that control, and we want you to have that control of that virtual private data center. But we do want to have the knowledge of when the relayer cache uploads to 120 providers for a row of data. We do want to know which providers and what sector IDs of specific sectors on those hard drives that data is going to. We want to know that information, because if we know that information, then we can start to provide some information back to folks, so that you can actually do things like match things up and do metadata recovery or restoration by matching those sector IDs with your original metadata backups and then some information that we provide. So what that means is, let's say you have a crash. You have a crash and you have to go back and restore your metadata. So you restore from where you were at. Now, we already agree that you're behind, right? You are not perfectly up to speed. There's some little bit there that you lost in the crash that you have to recover. Now, there's a couple of ways that, you could just get that data. You could just ask us, right? You could say, hey, what's the difference here? Tell me what you have. And if you trusted us, then we could just tell you and you could just get a contract recovered because you would trust us. But that kind of goes against the whole grain of this whole decentralization and what we're trying to build with this permissionless network. So what we're going to do is we're going to build it so that we have all of those validated and verifiable sector IDs that you uploaded to, and we'll show that so that you can match those to these contract changes that we provide to you. And you can say, yes, I agree. That's where I uploaded the data to. Thank you. Now my contracts are restored. And that's where we have it with the metadata. This is a gigantic task, by the way. This is a very big sprint that's going to have a lot of work behind it. So this is what our core engineer is lead developer is currently working on. The other thing that he just finished on this process is contract IDs, so that essentially he's got the ability to look back in history and say, oh, we put contract X and it tied up with all of these providers. We didn't have that ability up until now to go back in history and see these contract IDs. So what this is all related to is this keeping of this database of all of that layer 2 state channel work that's going on right now that's somewhat opaque. Right now, it kind of exists in a database, quote unquote, called Kafka, but it's not really easily accessible by anybody, including us. And so the next step for us is to turn it into sort of an addressable database where we can reach up in there and grab down from these events. It's an event sourcing data collector. So we can pull down from what are called topics and then be able to repair, recover, restore, do a lot of things. And we're going to talk about some really neat things that's going to allow us to do in some of these next slides. So that's the big task that you'll see coming up over the rest of this. Okay, we'll move on to the next one, which is removals, and that's Henry.
Yeah, so removals, I think, well, I'm glad that we covered all those bases over the last couple minutes, because that really is important. And although it was some nitty gritty like sector IDs, contract IDs, those fundamentals need to be in place so we can do things like removals, which are probably the last piece of the kind of life cycle. When you think about an object that gets uploaded to a cloud, lives there for a while, and then eventually gets garbage collected or gets deleted or something. That's where removals comes in. So removals today are done in such a way that we, the corporation, continue to pay for data even after a customer is finished with it. That's because up until now, or up until very soon, these kind of sector ID level granularity just wasn't a thing that existed yet. So to do true proper removals in such a way that as soon as somebody's done with a chunk, it can be deleted or removed, that is what is able to be enabled with the sector IDs. So removals is coming just after we do that refactor. The technology will be there to do that. Another consideration, though, is I said as soon as a customer is kind of done with an object or with a sector, it could be removed. That's where we start to have to remember and kind of consider the cloud service side. So what's pretty typical and standard in cloud data is that there's a minimum kind of retention period. So on services like, I think Wasabi, off the top of my head, it's like 90 days. Does that sound right, Ken?
I think it's 90, yeah.
Yeah, I think 90 sounds right. So we're so used to seeing advertised across different cloud services. We're so used to seeing $1 per terabyte number, like $7 per terabyte per month, or like $21 per terabyte a month. We're so used to seeing these prices, but there's so many kind of little hidden asterisks and things that it's really difficult to compare. Not all dollars per terabyte per month are equal, and this is one of the ways that they can differ. Are things like, even if you just uploaded a bit of data and only used it for a week and then deleted it, you can still be on the hook for another almost 3 months after that you're still paying for that data because that's just the minimum period. So that is a thing on every cloud. Every cloud has a policy one way or another, and that's what the minimum duration is. So video surveillance is an interesting kind of paradigm because that's typically... well, I think we all know what video surveillance is. So how long do you keep the tapes for? Do you keep them for just a week? Do you keep them for a month, for 2 or 3 months? That kind of thing fits right into that minimum duration and that retention policy. So what we're able to do that's kind of interesting with these removals, once they're powered by the sector IDs, is have pretty fine granularity over some of our partners who are more video surveillance oriented. They have the ability to kind of gain more power, I suppose, over how they determine the minimum retention policy. So if they want to advertise their video surveillance product as it backs up to the cloud for 30 days, even if that's below the rest of our cloud's kind of minimum retention, we would have the ability to kind of form some kind of agreement with them in order to potentially for a different rate or some kind of agreement made that would at least allow those kinds of products to work. Because if you are paying for 3 months worth of video surveillance when you really only think that you need 1 month, then that increases your footprint in the cloud by a pretty large factor. So this is a factor that's really important to our video surveillance partners, and that's why it has its own place in the list that we're looking at. So versioning and immutability as well. I think we're going to touch on that a bit later too, but without getting too much into how S3 is different from a file system, essentially S3 objects, when they're in the cloud, if we can differentiate them at a sector ID level, then we can also mark certain sectors as kind of locked in such a way that they either can't be modified or changed at any way. So immutability is really key for ransomware attacks. Backups up in the cloud, you mark it as immutable. That means no matter what happens, that data is going to be there. It can't be deleted, can't be tweaked, can't be modified. Even if somebody within your organization really wanted to make some damage, they wouldn't even be able to. Yeah, so the XMiner UI is something that we're all hopefully pretty familiar with. We have a sense of what it looks like. I think there are demo videos out there, so you can get a sense of what it looks like even if you don't have one. But anyway, I think for the last year and a half or so, it's stayed mostly kind of resembling the same. There's the financial page, the stats page, the settings, and all that. But as the rest of our portfolio and our stack and what we're working on has kind of evolved, there's a couple things that have kind of come up that make sense to maybe go back to XMiner UI, tweak some things. So it's become kind of clear that the financials page, for one, could use a bit more clarification, could use a bit of work. The contracts explorer, for example, that I remember when that debuted in the UI, that was pretty cool. But there are some important ways that could be kind of broken out to provide better access to the actual blockchain and in order to kind of visualize what's happening. Because as we even, I think, touched earlier on the call, if you really try to follow with a magnifying glass the financials of what's happening with a storage provider, it's pretty challenging because there are funds that are locked for long periods of time. The conditions in which it's either unlocked or not aren't always very clear, or even when that happens. So I think there's a lot of room to provide further insight, and as well things like historical payouts. So tax season, it can be important to a lot of people to be able to export and have a better sense of financially what events have taken place on the storage provider. Now, storage credits are something that we touched on, I think, 2 weeks ago. That maybe sounds right. But these are really interesting because we ultimately see a lot of the storage providers making up our network to be deployed by partners, because partners are people who are coming in and bringing probably a lot of data with them. And we expect it to make a lot of sense for partners out there to have their own kind of networks, I guess, of storage providers. Because if you're uploading tons of data to the network, it makes sense to capture some of that and earn and kind of pay yourself to an extent. So we foresee a huge amount of storage providers being deployed by partners. And to the rest of us, and probably most of the storage providers today, the reason why we set up storage providers are to earn the SCP tokens that have some value associated with them. That's the incentive. But if you are a partner and you're playing a bit of a different game, it works a little differently. And being rewarded with SCP tokens is still pretty good. Those can still be redeemed for something. However, it would be really neat if instead of involving SCP tokens and that being really what you earn, what you're earning, you're essentially just redeeming SCP token for what it's ultimately good for, which is storage on the network. So those storage credits, I think we already have working at the back end of our kind of main console system. but they would need to hook into the XMiner UI as well, and that feature would need to be developed at the storage provider end of things too. So that's coming. And finally, we have SSO tie-in. So that's a single sign-on. We have known for a while that it would be kind of ideal if to log into the XMiner interface if it kind of had the same authentication layer that the relayer gets, which is that you need to be signed into your console.xns.tech account in order to be presented with the main dashboard. And if you aren't signed into that particular account that's associated with that relayer, or in this case miner, then you don't get to get in. So we expect to implement that in pretty much the same way that we have it working today with relayers too, and that will debut in this refactor as well.
Couple of things on what he mentioned there. Two things: storage credits and SSO tie-in. So, yes, storage credits. It's kind of been a back and forth dance between front and back end, and I just saw today that the front end finished some stuff that the back end needed. The back end guy quickly put together his piece on it, and so now we're at a place where the next step is just getting the little button in the the window at the text entry, so that you can tell it how many SCP you want to convert into terabytes, and then we'll be able to roll that out. So I suspect that that'll show up in a pretty quick UI, and this is both for examiners and also just licensed full versions to convert those into storage credits. And then what happens there, and let me see if I can do this here real quick, because I think this is probably going to be a useful thing to do. Yeah, probably needed to log in. So let's log in. And then what'll end up happening is over here, you can all see this, right? Yeah. So what's going to end up happening over here is you will get your storage credits showing up over here. And when you transfer over SCP, and anybody can do this, even though Henry did say, yes, the initial impetus for this was to send this for partners, because the whole notion being that a lot of real customers are probably not going to want to deal with crypto at all. And the idea of standing up even, miners and so forth is going to be kind of anathema to them if they have to actually deal with crypto and selling it off and all that sort of stuff. So this notion of being able to set it on autopilot to go ahead and send over storage credits to offset their actual storage use is going to be a no-brainer. And so what ends up happening is that gets sent over into the console. That can sit there for the next year. What does fluctuate is when it comes time to convert that over into a credit that pays down a bill. So you go ahead and you convert your storage credits then into a coupon, and the coupons are also a new feature that's in there. And then the coupon actually then pays down the bill. Well, coupons are only going to be limited. They're going to be like, the minute you turn it into a coupon, what you have to do is convert when you're ready, and then that's when you ultimately, end up getting your credit paid down on your network. The second one is this SSO tie-in. Everything is going to be in the console. So you log into the console and you'll be able to see all your examiners. You'll be able to see all your licensed versions. You'll be able to see all of your relayers. You'll be able to see everything that you have brought to the table. And then at the end of the day, you'll be able to even manage everything right from there in that window. So the thing on the left-hand side, you'll click on an examiner, bang, it'll show up over in the right-hand side, and you'll have one screen to rule them all, and that's all managed from our single sign-on. So I just wanted to cover that real quickly. Relayer telemetry is an interesting thing that we really need to get out there. So right now, what ends up happening on all your devices is there are 3 scanners around the world. Sydney, Fremont, California, and London, if I remember correctly. And what ends up happening is they are always just rotating, scanning. And if you get marked by one of those scanners as being down, you don't automatically get downtime. You don't get shown as a red bar and being offline. What happens is that as scanner A, first of all, determines, hey, I can't contact this provider, it could be something between the scanner and you. So, it may not be your fault. You may be online and the scanner just doesn't see you. So, what we do then in the back end is we wait for the second scan. And if the second scanner doesn't see you, then that starts to add more evidence that you probably are offline. And I think it's to the third scanner before we actually truly count it as downtime against your provider. But at the end of the day, it's still three scanners around the globe that are scanning you, and that's still very centralized and very not efficient. Those things only scan you every 20 minutes, so it's not like you're getting this instantaneous sort of thing. And more importantly, it doesn't allow us to do a lot of things that are really interesting that we want to do. And so, first of all, where that all is going to be coming from for us is driving into every individual relayer a bit of software that does on the fly scanning or all the time scanning around the clock of a subset of provider nodes. So what does that mean? Well, let's say I stand up a relayer here in my hometown, maybe even at the address I just shared with you. I swear one of these days I'm going to look out the window and there's going to be some people out there and I'm going to say, why are you here? And it's going to be, well, we wanted to come see where you live. But the deal is that the relayer gets stood up, and then what it'll do is it will go out and it will scan providers. Well, not really effective to scan the whole network, right? Maybe today, 2,800 providers, whatever it is, could probably be feasible for the relayers to be scanning those, but it wouldn't really do much for you, right? Me scanning from Colorado all the way down to New Zealand, I'm not sure that there's a benefit to that in terms of, yes, I might be able to get an uptime or I might be able to get, just an availability, but I can't really do a true performance. Relayers will scan subsets of providers, so like any given relayer might scan, 1,000 providers around it. And there'll be like a geographical or some other kind of boundary that it'll use to determine which scanners that it provides. This actually exists right now, by the way. If you were to stand up SPD and run it, right? And instead of checking the -M thing that we currently have, which is usually GCTW, I'm missing one.
H.
But the whole,
host.
H for host. The other one that people don't check is R for renter, right? Because we're not using that. And the deal is if you did check R for renter, then what happens is HostDB goes to work and it keeps track of all the providers on the network. And you can actually go out and look at this HostDB printout to see exactly how people are doing, how their uptime, whether they're offline at any given time and a couple of other things. So we're drawing off of that gossip network and that current HostDB sort of infra. But again, like everything else, it has to be pretty much refactored, reworked, rewritten all the way from sort of ground up. But the idea of it is good. The idea underneath it is still very much sound, and that's what Rhinus is going to be working on. So that HostDB thing will end up coming in here. You won't have to run the renter. It'll be in the relayer software itself and so forth, and it'll be working off that gossip network configuration. So what ends up happening there is we can then take that information that's being shed off from all these individual relayers, pull it in and aggregate it in our network operations center, and then use it to provide actionable intelligence for customers, for people that want to use the network, for people that are storing data on the network. And more importantly, when you stand up a relayer, you will be able to reach out onto the network and pull down this decentralized performance gathering and then make determinations about where you want to save your own data. It may be the case that saving all of your data to providers that are within, 100 kilometers of your location makes a lot of sense from a performance standpoint. You may just choose, just give me the fastest that are in my region. But it may also turn out to be the case that there are a bunch of providers that you can choose around the network that will provide the ultimate in performance. And maybe if you're trying to get nothing but the fastest performance, both uploading and downloading, you may want to choose this subset of providers that are just blazingly fast, no matter where they're being pulled, P-O-L-L-E-D from. So in that case, what that allows us to do and what we'll do over time is we'll look at that and we'll say, okay, this is pretty cool because there is this subset of 10% providers that are just blazing fast no matter where you are and who accesses them. And their availability is always very good. And so they are this, tier of providers that are excellent, right? Well, if you're an excellent provider that lives in that top 10% tier, pretty clear you ought to be able to charge a little more money, or you ought to get more incentives. You ought to be a favored nation, because what's going to happen, right? Everybody's going to want to use you, right? And you're going to get your nodes filled up really rapidly because everybody's going to see that you are the best of the best of the best, with honors, sir. And the deal is that people will use up all of your storage quickly. So you should get some extra incentives for that. And by giving you extra incentives for that and filling up your storage quickly because the relayer customers want to use that, that's going to really signal to the rest of the network, well, hey, if I want that same thing, I'm going to have to do that too. And so that will encourage and incentivize everybody to try and do better in terms of, your ISP connection, your availability, your online, and all of the things that are around there. The current situation is we do have an S3 gateway running. Obviously, there's S3 compatibility, but what we put into place was we put in a deprecated version from Minio that has been around for a long time that provides really pretty good compatibility. And when we compare ourselves to others that are out in our sphere, we're okay. We can do a lot of things. And what ends up happening is that the S3 gateway, allows the access to the, RESTful API calls, but where most of the work takes place is in the third-party apps, right? So like, VM does a lot of things. And so you don't have to worry too much about certain kinds of calls or compatibility. But what is coming is this server mode. And this is the new sort of thing that Minio, works on today, their current version. There's some licensing issues. We aren't going to use most of what we're bringing over. We're only going to be using the gateway features, but there's these versioning, life cycling, object lock, a few sort of things like that need to be brought over. And that's where they live. So that's part and parcel of it. I don't think that this task is going to take all that long to do because we are only using a very limited subset. And, Pavel's already taken a look at it and thinks it's pretty, clean. So this is what Renat's working on. And I suspect he'll have this done probably in the next couple of weeks, several weeks. The next one on here is this relayer NAS device. And the reason why this gets its own piece is for a couple of reasons. So what it is, it's a piece of software and also probably going to be a hardware device at the same time. A lot of products are out there and services on the market today. I always use Cloudian as the example because they're just such a clean example. Cloudian has this device that they sell, but they really sell a piece of software, and that software is sort of a NAS aggregation tool. They can talk to multiple different clouds. They have their own cloud that they can talk to. So it's really this evolution from SAN to NAS. Over the last 2 decades, storage area networks have given away to these network attached storage devices with a lot of permissioning, network file systems on them, the ability to do various kinds of things in terms of immutability, ransomware protection, all of those kinds of things that are out there. So people are really now becoming very used to putting in these devices that sit at their network border and then talk to the various clouds. And it's become a thing now that it's, almost everybody that gets their data up into the cloud, that they don't just use one cloud. They'll have multiple clouds. So these devices are becoming very relevant and valuable traffic cop devices that can talk to multiple clouds and to be able to aggregate and to push data from one to the other or whatever, and how they need to do it. So this relayer NAS is really a device, and I think that we're going to do very well with when people start to realize our cloud is, very relevant and performant and, cost effective and so forth. So it will primarily start off probably as a branded server that we sell, but it will also be a piece of software that you'll be able to set up and run yourself as a SME or partner or as a enterprise price customer. But the real key of what it brings to the table is cache improvements primarily, cache changes to the cache configuration. Right now, if you put stuff into a relayer, it goes into this area called the cache. The cache then empties and drains up to the network. And then when the cache is empty, you're done. And then you can put more stuff in. What happens is the cache doesn't like do what I just described though. It doesn't, you don't load up a terabyte and then it goes up to the cloud and then it's gone. It sits there in the cache up to the size of the cache. So if the cache is 4 terabytes large, then you'll have the ability to store and hold 4 terabytes in cache while uploading 4 terabytes to the network. And then what ends up happening is when it comes time to actually access that data or use that data or recover that data, you pull from the cache. You don't pull from the cloud, right? You go get it from the cache because the cache is right there and it hasn't been evicted. What happens is once you hit that 4 terabytes or whatever the size of your cache is, it's a first in, first out mechanism. And then that data that gets deleted as new data comes in is the earliest that was uploaded. So some of the cache improvements we want to add are persistence. So you can mark something and say, well, look, I do want it to go to the cloud, but I also want it to never leave the cache. I want this data to always be there, performantly available to us in the cache. So we'll set them so you can mark the files or data or bucket or whatever so that it does that. Priority lanes are, let's say you have a division in your company where you need the stuff to get backed up right away, right? And everything else takes a backseat to this data. This stuff has to go up first, no matter what's going on. So those priority lanes, will be able to be set on a per bucket, per object, whatever kind of a thing. Immutable segments is ransomware, right? It's object locking, but it's also object locking not just in the cloud. Sorry, I look at my graphic and I love how my arms just disappear whenever I do that. I don't know if they're disappearing for you guys, but it's like a shiny toy and I'm a cat. So I keep looking at it and then I keep doing it. So the immutable segments would be also a ransomware section on the cache itself on that relayer NAS so that information that's right there on your premises would be object locked and immutable in case of a ransomware attack, and you could take care of that. Network file system is exactly what it sounds like, and that's a compatibility for the other clouds that are out there. So that's the whole notion of building in an open architecture. I'm just going to take that one. I think I actually had both of our names on that, but let me look at the next one here. No, I had my name on that one. You're the next one. Provider selection. Before Henry takes off on this one, I want to say this because I always say it to the developers, and I noted it clear back in 2018. This is going to be the most powerful and most important part of our project. I know it. I believe it. It's still the truth. It's still the case. It's really cool the way it works today. If you've worked in the relayer and you've gone out and grabbed a group of providers, it's really slick the way that we've set this up and how it works. And it's fun to work on, but it's going to get a heck of a lot better. So I'll let Henry take it from there. I just gave him such a big build up.
Yeah, sure. So provider selection, there is already a video out there that I encourage you all to go check out. I think it's on the XNS. If you go to the relayer tab, then there's a bunch of videos down the bottom. If you want to see provider selection in action, which I think if you are storage providers, which most of you likely are, this is the storage provider meetup, your home here, then I think it should be interesting to you of what does it look like from a relayer's perspective to pick you as a storage provider. So that, provider selection is kind of right at the heart of this engine. I'm going to try and do the best job I can of describing how the process works. I encourage you to go check it out and actually see it, because I think it'll really click when you see what the menu looks like to pick either on a map or use tags. So I think it'll make sense when you see it in action, but I'm going to use some terminology here that maybe you won't know off the top of your head. But so provider selection right now is performed in the relayer UI. You can do it either through a map or through actually like manually creating a string that describes exactly what you want. That's kind of considered a more advanced feature. So that's already in place today and has been for months in the relayer UI. But we're going to be migrating that to the console That'll be a trend that will continue, certainly in part two of this roadmap of things kind of being abstracted to more the console side. Um, so that provider selection will enter the console. That'll allow it so you can more easily pick your own storage providers for one, since we know a lot of our Relayer users and a lot of our partners also have storage providers. That'll make it much more straightforward to kind of pick your own groups and potentially apply them across multiple relayers too, since that will be a pretty common use. But the tags as well. So the tags are the different dimensions, and then you can think of them as kind of the columns in the table for your storage provider. So they have some factors like your location, your uptime. We're going to be adding more, like what we'd like to do with the gossip network and performance, be able to get some of that abstraction back. That's all going to live in the console, and yeah, the tags are just going to increase in abilities and what they're able to do. That process of actually creating a provider selection will only get more streamlined and be able to apply them to multiple relayers. That's just going to get easier. So, and it's already pretty easy, so that's nice. So yeah, new tags, performance, customer created kinds of tags. We'll have tiering as well. Ken, do you want to remind me on what you meant by that?
Well, tiering I already kind of covered a little bit earlier, and it's essentially that thing of the relayers are now going to have this ability to highlight and identify and sort of come to a consensus on the performance of any given provider, and then we'll be able to add that to the mix of other features that providers have out there and make little provider profiles. So what will ultimately happen is right now we have this regions, we have various kinds of selection criteria, but we'll also have a thing that says like tiering, and you may choose like a performance tier, or you may choose like a durable tier, or you may choose like another thing, and you just click that and it just goes out and grabs all the providers that fit that specific sort of niche. So the whole notion here is that we're giving you as much flexibility in building the virtual private data center of your dreams, right? In this process, in the console and so forth. So that's kind of the deal there. And I'll just close it out on that last one. The public sharing of sets in the console, that once we start getting this notion of having the ability of creating interesting provider sets, there's no reason why you guys won't want to share them with each other. And partners may put out special provider sets that they want to share, that they say, use my provider set, which has a bunch of my providers in it. And then maybe what they do is they turn around and give you something for that. Maybe they give you some storage, or they give you some other bonus, or, there's some other benefit that comes along with that, SPFs or something. I don't know, but there's a lot of potential possibilities there for incentivization to compete over who gets to get data and so forth. So that's really kind of a neat thing. This is listed in fourth quarter of 2023, but it's also listed in the first quarter of 2024. I'm suspect that we're not going to get to this quarter. It's just a bridge too far, I think, with all the work that we have to do. If suddenly an investor showed up and handed us a whole bunch of money, then I could go out and get another front ender. Yes, perhaps, but I don't think that's going to happen. Since I don't think that's going to happen, I sort of think this is the next quarter.
I did have one last thought about the public sharing of sets. I think that could go a really cool direction of having kind of little communities, particularly international communities. So we've seen, I think we even have them linked in our Discord, these like multi-language communities. So we have like a Benelux Telegram. There's, I think, a Spanish ScPrime, or like Spanish speaking kind of communities. And I think it'd be really cool if we started to see some of those sets kind of self-organizing and where they support each other as well. So if you're kind of in the group, I guess, then not only do you get kind of in on that set, but there's kind of a soft commitment to helping provide support to other people potentially within that group. So yeah, we've already seen some degree of kind of self-organized communities, either around some identity of a language or a region. But I think we could just see that continue and even abstract up to the set level. I think that'd be really neat to see.
Yeah, and that gets really to the heart of this whole idea that I've kind of elucidated at various points, that the network itself it already is a living organism. And we don't really have much of a network operations center right now, but it's something I definitely want to build and grow and really drive, because I really feel like we're going to build out these tools over the next 12 months that really allow for this dynamic ability to use this product. But all that's going to do is just open up windows into a lot of things that we can do. And so, like, for instance, when we talk about having this host DB activity going on from relayers, plumbing the network to see what performance looks like, it's going to be aggregating this huge amount of data at any given time of what performance looks like from all these individual places. And then what's going to need to happen is we're going to need some way to aggregate that to say, well, what's an average? If a provider in California is being pulled from New York and has a certain performance, profile, but then it's also being pulled from, say, Hawaii, and it has a different performance profile there, and then it's being pulled from Brazil, and it has a different performance profile. You get these three performance profiles, and you can aggregate them and average them and come up with a number that might be relevant to the network as a whole. And if you take that over time and look at those averages, you now come up with something that's even more actionable in terms of long-term intelligence. It doesn't take very long to recognize that when we get to 100,000 providers and we have that kind of level of, 10,000 relayers that are all doing that same kind of level of work, it's not something a human's going to be able to do. And it's not something that a simple timescale database is going to be able to do. It's really going to require machine learning, and it's going to require something like an event streaming tool to really be able to tackle that. This is something that those big hyperscalers can't do today. Dozens of locations with millions of terabytes. What we are is completely the opposite of that. We're going to be millions of locations with dozens of terabytes, right? And so in that world, having this ability to do this really granular machine learning and to really understand this living organism of this network that you guys are building right now, that you're part of, is going to be really fabulous and really powerful. But one of the things that I see happening very rapidly on our thing, if you look at object stores right now out there online, the whole world has sort of evolved to this place where object stores are becoming the primary cloud service storage. Block storage had its day, file systems had their day, but object stores are really turning out to be the thing. And one of the things that's happening with object stores that's really powerful right now is that there's a lot of this big data lake work that's going on. So what they will do is that enterprises will upload giant stores of data, and it's just, unstructured flat file data, right? So PDFs, videos, you name it, any kinds of files that they have, they just get all uploaded. And, maybe there's good hierarchical directory structures, maybe there's not, but it just all gets dumped up there. And for a long time, you couldn't really do a lot of good analytics on that data. You couldn't really get a lot of actionable business intelligence out of that data because it was just big, giant, unstructured objects, right? Well, now what's happened is a lot of companies have emerged on the scene in order to be able to do all that analytics work and to provide really profitable, valuable business intelligence. Snowflake is an example of that. There's a probably 30 or 40 companies that have really rocketed to very high valuations and profiles because they have that ability. There's literally nothing stopping people from doing that exact same thing on our network. There's nothing stopping somebody from putting a 50 petabyte data lake up on our network, then connecting Snowflake to it and running complex analytics on it. It's really all about the quality of the partners that we're able to onboard over the next 2 to 3 months and how they get out there and start to trial different kinds of things on the network.
Then yeah, the whole second half of the roadmap, there's some really cool stuff in there that maybe just the name alone doesn't jump out to people, but yeah, I'm looking at some things that I like, relayer meta, that the whole snowball thing. There's some really cool stuff coming that I would love to be able to just scratch the surface of what's possible and help make that click for the audience too. So thanks everyone for joining us this week. Thank you for coming.